Hey everyone, my name is Anson. Today I'm going to teach you all how to set up microservices in Nest.js. You're going to learn what microservices are, how they differ from traditional monolithic applications, and how to use a NATS server to communicate with each microservice. Now, in order to understand what exactly is a microservice, we need to understand what monolithic applications are. And in fact, many developers like yourself are used to building them already. Typically, when you're building an application, you have only one API that has all of your endpoints defined for your front end. For example, let's say you have an e-commerce website that has to handle user authentication, it has to handle payment processing, order confirmation, and many more domains. In your monolithic app, your API server will handle all of those API requests. It will produce some kind of output, and it will also send that as a response back to the client. This means that you have one single process doing all the work for the clients, and if your deployed machine that is running the application has limited resources, you can start to see performance issues. Instead of having that single API do all the work, you can have each microservice perform the relative task and send it back to the API. So that kind of divides the work from having just one single API, one single process doing everything, into different components doing different things. So you have not only one process, but multiple processes doing the work for you. So I have a simple diagram for you to show you what a traditional API server that handles these requests would look like. So you have your clients, they will send GET requests, POST requests, whatever it is, they'll send it to the API. The API will talk to a database or some external API, some external source. It will perform some kind of computational work, produce some output, send it back to the client. Now again, like I said before, depending on what the business logic is, it can become very expensive and it can start to bottleneck your application. And what you can do is, instead of having just one API doing everything for you, you divide that into different microservices to handle different payloads. So I'll show you a diagram that I drew out of what a microservice architecture can look like. Now, there's no right or wrong answer to approaching this because it really depends on your business needs. What you're seeing right over here may not be suitable for a different approach for a product, but it could be the right approach for a different product. So I'm mentioning that because it really depends on the software architect, on how they want to design a system that is scalable and how it would work. So like I said, there's no right or wrong answer. It really just depends on the type of problem you're trying to solve. So right over here, you can see that I have 4 clients, and there can be as many clients as you might need or as you might have. And we have, let's say, a GraphQL server or an HTTP API or even both. And they talk with a NATS server. So your clients will send either a query to the GraphQL server or send an API request to the HTTP API server. And instead of having all the work being done on the server, what you're going to do is communicate with the microservice. Now, there are different ways on how you can communicate with the microservice. Sometimes you might actually just use an HTTP client to forward the request to the microservice. But in our situation, since we are using Nest.js, they actually define a microservice, and I'll show you right over here. They define a microservice application that uses a different transport layer than HTTP. So the standard in Nest.js is your microservices actually don't use HTTP. They still use TCP, but they use different transports such as Redis, NATS, RabbitMQ, Kafka, gRPC, and many more. Okay. Again, you could use HTTP if that's all you need, but NATS is also another popular approach to sending the messages from the API to the correct microservice. So in this diagram, you can see right over here that the GraphQL server or the API server can forward that request by simply publishing the message to a NATS server. Now that NATS server will receive that message and the payload if there is any data that it needs to process and deliver to the correct microservice. So you can see right over here I have a User Microservice, a Payments Microservice, and I can also have an Activities Microservice to track user activity. The NATS server will deliver the correct message and its payload to the corresponding microservice. The microservice needs to subscribe to the NATS server in order for it to receive those messages and its payload. Once it does, the microservice can process the logic that it needs to do for that domain. It can read and write from the database. It can talk to an external API. It can do whatever it needs to do. Once it's done, it will send back the result to the API or the GraphQL server, and it'll send it back to the client. So hopefully all of this makes sense. Now what we're going to do is we're going to set up the project. So there is a lot of setup involved in this, so don't feel discouraged. I'm going to walk through everything step by step for all of you. So the way that we're going to set up our project is like this. We're going to have a total of 3 Nest.js projects all together. We're going to have our API layer, so this HTTP API that you see in this diagram. We're going to have that API that is going to receive incoming HTTP requests. We're also going to have 2 microservices, one for users and one for payments. And those microservices are not going to be HTTP APIs, but they will be TCP-based applications that will be subscribing to the NATS server. So that's how they will receive the messages and the payloads. And they will also send messages to the NATS server as well, if it needs to. We're also going to have the NATS server that will be responsible for acting like the middleman between the HTTP API and all of our microservice. That's how we're going to transport the data from the API to the microservice. Okay? And we're going to have one single database that is going to be shared amongst each microservice. I know in the diagram I showed how each microservice connects to its own database. Typically you can do that, but it really just is based on your application. Sometimes you might have each microservice connected to its own database. Sometimes you might have multiple microservices sharing a database. It really just depends. Just to keep things simple, we're going to share one single database for all of our microservices. Okay? We're going to be using a SQL database, and I'm also going to be using type ORM, but you can also use MongoDB if you want to as well. So hopefully all of that makes sense. We're not going to be using any GraphQL at all. And we're going to be combining everything all under one single Docker compose file. So we're going to be running everything in Docker because it just makes it so much easier. You don't necessarily need to use Docker, but I highly encourage you to use Docker for this because it makes it so much easier to run everything all together in one single container. Okay, so let's go ahead and actually get started. So what we're going to do is we're going to go into our terminal, Windows PowerShell, and we're going to set up a single folder that is going to host all of our Nest.js projects. So I'm going to call this Nest.js Microservices tutorial. Okay, I'm going to cd into this folder. And then what I'm going to do, let me zoom in a little bit, is this. I'm going to create a new project. This will be our root API is what I'm going to call it. That's going to be the entry point to our entire application. So it will be our HTTP root API. So I'll call this, let's call this HTTP API gateway. Okay. We're going to use npm. And while this is scaffolding, we're going to need to set up the dependencies that we will need. So luckily, we're not going to need too many dependencies. The only thing that we will really need to install is the Nest.js Microservices package, the NATS package, because we need to connect to the NATS server. And I think that is it. Okay, so I just finished generating the new Nest.js project. I'm going to cd into this folder, and we need to install two dependencies. The first dependency is going to be the Nest.js Microservices package. So that's going to be right over here. We need this in order to actually set up the microservices. And we also need to install the NATS package as well, since we're going to be using a NATS server to deliver the message to our microservices. So let's go back to our Windows PowerShell, and we'll type npm I at nestjs/microservices, and then space, and then NATS. So two packages. Okay. Should be pretty straightforward. So we just installed both of these packages. And then now what I'm going to do is let me open up my Visual Studio Code. Let me move this over to the other screen. Okay. So there's a couple things that I'm going to do inside this HTTP API Gateway project. The first thing that I want to do is I simply want to set the port to be a dynamic port. So we're going to use process.env.port, and this will be an environment variable that we will set in Docker Compose. And if the port is undefined, we're going to use port 3000. And I'm going to just simply pass this port in, and I'll pass a callback function that will log what port we're running on. So running on port. So that way we know what port we're running on. Okay, so remember, this project is going to listen to a port to take an API request via HTTP. We still need to make sure we can connect to the NAT server. So to do that, we need to go inside our root module app.module.ts, and right inside the imports array, I'm going to reference client's module, and this comes from the Nest.js Microservices package that we just installed. We're going to call this register method and pass in an array. So we need to pass an object in the array, and the name, you can call this whatever you want. I'm going to call this NATS service. Okay. We need to set the transport, and the transport that we're going to use is going to be NATS. So we need to import this from the Nest.js Microservices package. It's an enum, and you can specify the transport that you're going to be using. So they have different transports, but we're going to be using NATS. So I'm going to select NATS. Okay. And then finally, we need the options, and we're just going to set the servers. This is going to be an array of all of the NATS servers we want to connect to, but we're only going to connect to one NATS server. However, you could connect to different NATS servers if you want to, but just for this tutorial, we're going to use one NATS server. So we need to specify the protocol. So it's going to be NATS and then : //. And then what we need is we need the host name of the NATS server. Now, since we're going to be using Docker to actually host and run the NATS server, I'm going to actually set the host name in the Docker Compose service section. I'm going to set the host name to be NATS like this. However, if you're running your NATS server on your local machine, or if you're running it on some deployed server, you will need to make sure you have that machine's host name. Okay, so for example, if I was running it locally on my actual Windows computer, I would use localhost. We don't need to specify a port, because by default, the port is going to be 4222, and we're just going to use that port. But if you did have a custom port configured, you will need to specify this right over here. I'm not going to do that because we're going to use the default port, which is 4222. So we're done with this, and all we're going to do next is just delete the generated controller and service file that Nest.js did. You don't have to do this. I'm just going to do it myself because we're not going to be using it at all. So let me delete the service file, and let's see. Okay, so for now, we're done with this root project. Okay, so what I'm going to do next is I'm going to set up a Docker file real quick, and I'm actually just going to copy and paste this Docker file into this project, or the contents of the Docker file, and it's just going to be pretty straightforward. we're going to use node version 18. We're going to specify our work directory. We're going to copy the package.json files and the package lock.json file. And then we're going to run npm install and then copy the rest of the contents. Okay. I also need a Docker ignore files. So let me also just copy and paste that as well. And like I said, just go ahead and grab the Docker file from the GitHub repository. So that way you don't have to just type all this out. Or if you want to type it all out, it's fine. I am going to quickly set up a simple Docker ignore file. And just for now, I'm going to have it ignore the node modules folder. And then you can also have it ignore the build files as well. But I'll just leave it like this for now, because we definitely don't want to copy over the node modules folder into the Docker container file system. Okay, so let's see. The other thing that we need to do, and I think you only need to do this if you're on Windows, or if you have any issues with the Docker container not auto reloading whenever you're making changes to the project. So what I'm going to do is inside my tsconfig.json file, I'm going to copy these watch options settings. And this is just pretty much going to use dynamic polling instead of the system native events for file changes. So like I said, I think this problem mainly occurs if you're on Windows, but if you have any issues with whenever you're making changes to your code and Docker is not reloading the changes, it's not restarting the server, so the hot load is not reworking, then just add these watch options in your tsconfig.json file. Okay? And like I said, you can grab this from the repository as well, or just look at this part and just type it in. Okay, so this will ensure that we actually can auto reload our process whenever we run it. And keep in mind that we are also doing everything in development mode. So obviously in production mode, you wouldn't actually have watch options set up. This is only for development mode. Okay, so we are done with this project for now. We next need to set up our other microservices. So I'm going to go into the PowerShell. I'm going to cd back into the root directory. So inside Nest.js Microservices tutorial. And I currently only have one project. We need to create the other two microservices. So we're going to create one for users and one for payments. So Nest new users microservice is what I'll call it. And we'll do the same setup, use npm. And then I'm going to do the same exact thing with payments microservice. So I'll get back to you all once I created these two projects. Okay, so I just created both the users microservice project as well as the payments microservice project. The same exact setup. I didn't do anything with it yet. I did not install any packages at all. So what we're going to do first is we're going to configure the users microservice first, and then we'll go over to the payments microservice later. So let's go into users microservice directory, and we're going to install the same packages that we installed in our HTTP API gateway. So I'm going to install @nestjs/microservices, and I'm also going to install NATS as well. So once we have that installed, we then need to, let's open up the project. So let me actually do this. Let me cd back into the root directory, and I'm going to open up VS Code in this root directory right over here. So that way you all can see all three projects on the file explorer. And I'm going to go into users microservice, and let's just verify we have our packages installed. We have microservices and NATS. Okay, perfect. All right, so now let's just quickly configure the tsconfig.json file with the same watch options settings that we put in the API gateway project. So I'm going to copy that over and just paste this inside here. And I'll do the same thing very quickly inside payments microservice. Like that. Okay. We're done with that. Let's go into the users microservice inside source. And we'll also delete the app controller.spec file and the service file because we're not going to need that. And let me just delete these imports and references as well. So we need to go inside the microservices main.ts file. So inside right over here. And remember how I said earlier that the microservice is not going to listen to a port. So we're going to remove this part. And we're also going to configure this app as well. So instead of calling nestfactory.create, we're actually going to call nestfactory.create microservice. And we're going to type annotate this method with the microservice options type right over here. And then we're going to pass in the app module as well. And we're also going to pass in an options object. So we need to set the transport to NATS. So we need to import the transport enum. And then we need to specify NATS, since we are using NATS. And then we need to connect to the NATS server as well. So options, which is an object, servers. And it's going to look very identical to how we connected it from the API gateway earlier. So if you look right over here, it's going to look similar to this. Okay? Except we're not doing it inside the app.module.ts file. We're doing it inside the main.ts file, inside the bootstrap method. So let's pass in the connection string. So NATS protocol, and then the host name is going to be NATS. And then we just simply do app.listen, await app.listen, and that's it. So we're still calling the listen method, but we're not passing a port. Okay, so this will start the microservice, and this will subscribe to the NATS server. And then we can later start to receive messages from the NATS server. So we do need to set up a Docker Compose file. So that way we can not only build out all of our projects into one single Docker Compose script and container, but we also need to use it so that we can run our SQL server as well as the NATS server as well. So I'm going to go and create a new file inside the root Nest.js Microservices folder. So basically outside of all three of our Nest.js projects. I'm going to call this file dockercompose.yml. And you can just copy and paste this file if you already know how Docker Compose works. But for those of you who are not super familiar with it, I'll still explain everything that we're doing. So we need to set up this service right over here. So I'm going to go ahead and write services and then colon. And right underneath, I'm going to hit tab. And I'm going to go ahead and name the first service API Gateway, which will be for our API Gateway project. So right underneath, we're going to use the build, and then we're going to have it target the HTTP API Gateway project. So we need to pass the relative path to that folder. So basically, this will look inside this folder to look for the Docker file and run all of these instructions. Okay. The next thing that we'll do is set up the ports. So since the API gateway is going to run on port 3000, we're going to expose the internal containers port 3000 in the Docker Compose file, and we're also going to map the Docker's host port 3000 to the internal port. So for us, when we run our Docker container, in order to actually access the API gateway, we need to go through port 3000, and that will kind of like forward that to the internal Docker containers port 3000. So we're going to do port, oh, whoops, we need the dash as well. So 3000 colon 3000. Okay. And this will pretty much do the exposure of the port for this API gateway container for you. So notice how in the Docker file, I did not expose the port in the Docker file. I'm doing it in the Compose, the Docker Compose file. Now I am going to set up a simple volume, and pretty much we're going to mount our source folder into the actual Docker container. So that way the Nest.js process that is running in the Docker container will see the code being updated, and then it'll restart the process in the Docker container. So we actually need this in order for the hot reload to work as well, aside from just having our watch options configured. So I'm going to just copy and paste this because I do have this already set up. So what I'm doing here is I'm saying I want to, let me actually change this because this is actually from my live stream that I did, because I did this setup as well live, but the folder is going to be http/API or -API-gateway, and we're going to target the source folder inside, and then we're going to mount it to the work directory that we set up in our Docker file. So that's user source app. So we're basically mounting it to the Docker containers file system. So user source app and then /source. So whenever I make changes to, let's say, main.ts inside the Docker containers user source app /source folder, it will have this main.ts file and it'll also update it as well. Okay. I know it can be a little bit confusing, but what I encourage you to do is make an update to your local main.ts file and then go inside your Docker container, the file system, and look at the changes being updated, and that will help you better understand how this mounting is working. But don't worry so much about it for now. Just know that you need this volume in order for hot reload to work. Otherwise, you're going to have to keep restarting it manually every single time. I'm going to go ahead and use the command, and I'm going to have it just simply run our start dev script right over here. So it's going to run npm run start dev. And then we're also going to pass in an environment variable by using this environment right over here. And we're going to set the name to be port and the value to be port 3000, just like that. And we're done with our API gateway. We're going to do one more for the users microservice. So let's just call this users microservice. And we're going to follow very similar things that we're doing in our API gateway setup. So we're going to specify build, and we're going to have it target the users microservice folder. So we're going to pass the relative path. So again, this will look inside the users microservice. We need to actually get the Docker file for this. So let me go ahead and actually just copy this one. And I will go ahead and create this right now and paste this in here. And I'll also copy the Docker ignore file as well. Or I'll just create it. So Docker ignore. So that's dot, in case you can't see this, it's .docker ignore. That's the name of the Docker ignore file. And we're just going to ignore the node modules. Okay. So again, it will look inside the users microservice, and it will look for the Docker file in there and run all of the instructions over here. Okay, so remember, the microservice is not going to listen to any port at all. We actually don't even need to expose any ports for this because it's going to connect to the NAT server. So we don't need to specify any ports, but we will do the same thing with volumes. So that way, when we are making changes to our users microservice project, it will update on the Docker image file system, and the Nest.js process that is running on the Docker container will detect those changes and restart it. So I'm just going to copy this volumes right over here. Whoops, paste that right here and just change the reference to users microservice. And then this will basically mount this into the Docker container or the Docker image file system. Okay, we're going to have the same command. So let me just paste that right here. And I think that is it. So I'll quickly just copy and paste this for the payments microservice, so we don't have to do this. Or I'm sorry, payments microservice. So that way we don't have to do this later. And I'll just change everything from users over to payments, and it's going to look exactly the same as users microservice. And any other microservice as well that you might set up, it will look identical to this, unless if there are any other things that the microservice might need, then you might need to configure it differently. But for now, this is what we have. Pretty straightforward. And finally, let's configure the NATS server. So we're going to specify NATS. So remember how I said earlier that the service name right over here, this is the NATS service name. This is also going to be the host name as well. So that's why we don't need to worry about the host name over here, because it's going to be the same thing. And since you're using Docker, remember Docker has like its own network system in place. So you actually can't even connect to the NATS server directly by just passing in like localhost like this, since you're running in a Docker container. I think there are different ways that you can do it, but it requires additional things that you have to do. So just to keep things simple, we're just going to use the host name of whatever the service name is right over here, which is going to be NATS. Okay? So hopefully that part makes sense. We need to specify the image. So Docker will pull the NATS image down, and then we just need to specify the ports. So really, we just need port 42222. So 4222. Sorry, not 42222. It's port 4222. And we'll just map the Docker host to the internal port right over here. Okay? So now all of our services should be able to connect to our NATS server via port 4222. Okay, so for now, this is all we need. Later on, when we get to MySQL, we'll do that later, but let's just keep it simple for now. And what I'll do is, let me just go into my terminal, and I'm in my root project directory right over here, and I'm going to run docker-compose up-build, and let me open up my Docker desktop GUI. And I also forgot that I need to actually run Docker as well. So make sure you have Docker running, of course. Okay, so I have my Docker desktop graphical user interface right over here, and the Docker engine is also running. So let's go ahead and run Docker compose. Let's see. Seems like we got this error, and it says no such file or directory. I think it's complaining because one of our projects does not have the Docker file. And yeah, it makes sense because I think we set up this payments microservice, and the payments microservice doesn't have that Docker file. So let's actually just simply copy it over. So let me just copy the Docker file, and then in payments microservice, I'll paste this right here. So now I have the Docker file here, and I'll also create the Docker ignore file, or just you can just paste it, but since it's just a simple one line of node modules right over here, I'll just create that. All right, so let's try running that command again. Okay, there we go. Now it's actually working. Okay, it's running npm install for API gateway. Now it's installing the packages for users and payments. Okay. We'll take a little bit of time because obviously it has to install all of the dependencies. Okay. All right, and now let's see. Okay, so it seems like everything's good. All right, perfect. So everything is running. Let's just go into Docker, the graphical user interface. Let's make sure everything's up and running. So no issues with the payments microservice. If there was an issue with connecting to the NATS server, it would say right over here. The NATS server is up and running. You can see the logs. The NATS server is right over here. It's listening for client connections on port 4222. API gateway is up and running on port 3000. So that is also working as well. Let's see. I think everything is good. Just very quickly, what I'll do is in the User's Microservice, I'll just show you very quickly that if I were to change something in here, let's just say console log, User's Microservice is running. And if I save, you can see now it auto reloads and it has my changes right over here. And remember how I said earlier, you can just go into the files right over here, and you can just look in the, let's go to the work directory. So it's going to be user source app. Yep, right over here. And you can look in the source folder and then main.ts, and you can edit the file over here. Obviously, you don't want to actually edit it, but you can see the changes right here. Okay, so whatever you update on your actual local file system, it will be reflected onto here because we have the volume set up. So I just wanted to very quickly show you all. Cool. So let's actually do one more thing. If I actually mess up this connection, let me just change the host name, and it will take a little bit. You can see now the logs. Remember how earlier it was logging like a few more lines, and now you only see these two things being set up? That's because the NATS connection is actually failing, because we obviously don't have this host name correct. So you can see that right over here, it's failing to connect to the NATS server. So just wanted to also show you that as well. Okay, now that we have all the hard things set up, we can actually start to set up our API gateway to take in API requests, and then we can send messages to the user microservice, so that way the user microservice can perform its business logic. So basically, we're going to communicate from the API. We're going to communicate with the API to the NATS server, and the NATS server will send that message to the microservice. So we need to go into our HTTP API gateway project, and what we're going to do is we're going to set up a users module. So let's create a new folder called users, and let's create a new file called users.module.ts. And I'm going to import the module decorator from Nest.js common. And let me just pass in the metadata for the module. So we need imports, controllers, and providers as well. And then we're going to create a class for users module like this. Okay, so the next thing that we're going to do is we're going to create a user controller. So users.controller.ts will be the name of the file. And then we're going to go ahead and create a class called users controller. And let me use the controller decorator, which is going to be imported from Nest.js common. And we're going to map this route to be users. Okay. So now we need to create a route to handle whatever it is that we want to handle. So we're going to set up a create user route, which is going to be a post request. So I'm going to use the post decorator, and then I'm going to decorate this create user method. Okay. So whenever we make a post request to /users, it's going to go ahead and call this create user method, because this route is mapped to this method right over here. And this method is going to need to not interact with a database, but it's going to talk to the NATS server. Because remember, now we're building a microservice architecture, so we're not interacting with a database in this controller. We're not interacting with anything else but the NATS client. So what we need to do is we need to inject the NATS service into this user's controller. So remember how earlier when we went into app.module.ts, I had this client's module.register method being called over here, and then we passed in this object that had this NATS service defined. So we need to inject the NATS service into our class right over here. So we can do that using the constructor. So constructor, and then inside the constructor args, we can just do, we can use the @inject decorator, and the token is going to be the same name that we provided right over here. So it's going to be nats_service, all in caps, like that. And then we just do private, and then you can call it whatever you want. I'm going to call it NATS client. And then the type annotation for this will be client proxy, which is imported from the Nest.js Microservices package. So this will now allow you to access the NATS client, and you can use this to communicate with the NATS server. So you can either emit events, you can send messages to the NATS server. We're going to use two different approaches. I'm going to show you how we can do request and response approach, and I'm going to show you how we can use event-based approach. Okay, so what we're going to do now is we need to allow this endpoint to take in a request body. So that request body will contain data that is used to create the user. So we'll have stuff like a username, email, display name. We're going to take that request body, and we're going to send that request body to the NATS server. The NATS server will then forward that message to its subscribers. So in this case, we have our users microservice subscribing to our NATS server. Okay, so you're going to see how we can forward this message all the way to the user microservice running on its own process. Okay, so let's go ahead and do this. We need to register our users module in the app.module.ts file. So right over here, I'm going to go ahead and import users module like this. Okay, and I need to also go into users module and import the users controller class inside this controllers right over here. So users controller. Okay, so that way we actually are registering our users controller in our entire gateway application. So if you go back into Docker, let's look at the gateway application. Okay, so you can see that we actually have a problem. It's complaining about not being able to resolve the dependencies of users controller. The reason why this is happening is because the users controller is using the NATS service, but the users module does not have that injected over here. So there's two ways that we can approach this. We can either copy this whole thing and paste this inside the imports part for the users.module.ts file, but we're not going to do that because we're going to need to use the NATS service client in a lot of different modules anyways. So the best thing to do is to create a separate module. So we'll do that right now. So I'll create a module called NATS client like this. So I'll create a new file called NATS client.module.ts, and all you're going to do is just create a simple module. So export class NATS client module, and then pass in the metadata, and then imports, and then you're just going to paste in this whole thing. Let's import clients module and import the transport enum as well. And then what you need to do is you also need to add this inside the exports array as well, like this. So now you can import the NATS client module in your users modules import section right over here. Okay, and then inside app.module.ts, we can just remove, let's remove this part right over here. And now we can see the logs, the errors are all gone. Okay, so pretty much this makes it more modular. So when we get to working with the payments microservice, we're going to create a payments module as well, identical to the user module. And we can just import the NATS client module and use it instead of having to copy and paste, this whole client's module.register everywhere. Okay, so hopefully that makes sense. All right, cool. So we can see that our API gateway is working just fine. There are no issues. You can see the user's route is being mapped right over here. And you can see right over here, if I go into Postman and make a post request to /users, you can see that we're getting a response back. It's not doing anything, but we are getting a response back. So that's good. All right, so now let's create a DTO for our create user payload. So I'm going to create a new folder called DTOs, and I'll create a new file called create user.dto.ts. And DTO is a data transfer object. It pretty much just is an object that has the corresponding field mappings. So in Nest.js, it's pretty much just going to be a class. So let's create a class called create user DTO. And we're going to use this class to type annotate our request body as well. And you can also use the DTO to set up validation. So I'll show you how to do that as well. So let's just define the fields that our request body will need in order to create a user. So we'll need a username, of course. We'll need a display name. and an email. And I'll make the display name optional. Okay. Now, if you want to have validation for your payloads, we can use a package called class validator and class transformer, or sorry, two packages. So let me go ahead and install that. So I'm going to go into my Windows PowerShell. Let me just kind of exit this process, and I'll cd into users, or not, I'm sorry, not users. I'll cd into the HTTP API gateway, and let me install class validator and then class transformer. Okay, and this will give us a bunch of different decorators that we can use to mark each field as optional or non-optional. We can mark it as if it's supposed to be a string, a number. There's many different decorators that you can use to ensure that each field is what it's supposed to be. Okay, so let me go and run the application again. All right, so our project is running again, and we need to make sure we enable validation. So there's two ways you can do this. You can either enable it globally for your entire application, or you can enable it for each endpoint. I'll just make it simple, and I'll go into my main.ts file, and I'll enable validation globally. So it's very easy. Just go inside the bootstrap method, and you reference the app, the Nest.js app instance, and you're going to go ahead and just call this use global pipes, and then you pass in an instance of the validation pipe, which is imported from the Nest.js common package. Okay, so app.useGlobalPipes. So this will enable validation globally. So now we can go back to our DTO class, and we can use decorators to specify which field we want to be required, which field that we want to be optional. So for username, I can use this is, let's see, there should be required is not empty, I guess. Is not empty. So this will ensure that username is not empty. I figured there would be a is required decorator. I don't know why, but there's let's see, let's do is string. Let's import that is string, and make sure that it is the capital is string, because there's also the lowercase is string like this one, and this is not the right one for the decorator for the field. Okay. You can also do max length. So let's say if you don't want the username to be more than 32 characters, you can do that. Let's import that from the decorator, the class validator package. And then for display name, I'll do is optional. We'll make sure it's also a string. And then max length, we can set that to maybe, I don't know, let's do 64. And email, we'll just do is not empty, so it has to be required. We can also use the is email decorator as well. So that means that it will make sure that an actual email is being sent in the payload. And we'll just leave it like this for now. Okay. So now going back to our users controller file, we can go ahead and grab the request body that is sent to this endpoint inside the method's arguments right over here by using the body decorator, which comes from Nest.js common. So body, and you just call that decorator and just give the name for the method argument. So I'll just call this create user DTO, and I'm going to type annotate it with create user DTO like this. Okay, and just very quickly, I'll console log this. And let me go into Postman and show you how this is going to work. So if I try to click send, it's going to throw an error because we are not passing in any username, no email. And it also gives you a message right over here as well. You can also provide custom messages if you want, but we're not going to do that. Custom error messages. So let's pass in a username. Let me also set the text, or set the request body type to a JSON. So let's do username Anson and email. Let's do Anson at ansonthedev.com. And now we should no longer get any errors. And notice how if I pass in an invalid email, it's going to say email must be an email. If I don't pass in a username, it's only going to complain about the username right over here. So hopefully that makes sense. And you can test this out yourself as well. Okay. And of course, if I don't want to pass a display name, I can omit that from the request body, but I'll just pass one for now. Okay. And if you look at the logs, let's go into the Docker container API gateway. You can see that it is being logged right over here. So we know that we are receiving the validated request body. So that's pretty cool. So now let's actually send it over to the User Microservice. Okay, so this is actually very simple. All we need to do is just reference the NATS client and call send. And we need to pass in a pattern. Now, the first way that we are sending messages to the NATS server, which will send it to the User's Microservice, is we're using request and response, the request and response approach. So I'll actually show you in the docs right over here. So there's the request and response message style, and there's also event-based. So we're doing it request and response first. So there's pros and cons to both. So for example, let's say if you really need a response back for the client, then you would want to use request and response approach. Sometimes you might not necessarily care about a response. You just want to be able to publish messages to the NAT server and then have the microservice receive that message and perform logic, and that's it. You don't care about what the client is going to receive as a response. Then in that case, you can use the event-based message style. Again, we'll cover both in this tutorial. Okay. So what we need to do is we need to pass two arguments. So the first argument for the send method will be an object, and it's going to have this property called command, and it's just going to be a string, and you want to have it represent an actual command, an actual pattern for the microservice to receive. So the way that's going to work is we're going to call this command create user, just like this, and then I'll show you how we can receive this command on the microservice. And then the second argument is going to be the data that we want to pass. So we'll pass in create user DTO like this. All right, so for now we're done with this. We'll leave it like this for now. I want to show you how we can actually receive this message from the user's microservice. So let's close this user's controller file. Let's go into the user's microservice project, and we're going to go into source folder, and I'm going to go ahead and create a users module as well for user microservice. Okay, so let's create that. I don't know why my TypeScript server is a little bit messed up. Okay, but I do need to import this from. Oh, actually, you know what? Let me make sure. Let's see. Nest.js microservices. Yeah, it should be fine. So let me just import module from @nestjs/common. And then let's specify the imports, controllers, and providers, which are all going to be arrays. We're going to go ahead and create a new file called users.controller.ts. And now this time, since we're inside our microservice, this controller is actually not going to be a regular HTTP controller like we had in our API gateway project, like this one right over here. This is actually going to be a microservice controller. So let's create a class, and we're going to call this users microservice controller, just so that way it's not confusing for you all. And then we're going to use we're still going to use the @controller decorator as well, which we do need to import from @nestjs/common. But this time we're not going to provide any argument inside the controller decorator. You can see if I hover over here, it actually tells you that there is two definitions. There's an HTTP controller, And then there's also a microservice controller as well. Okay. And you can see over here that it responds to requests for the microservice controller. It can respond to requests as well as events running over a variety of transports. In our case, we're using NAT. Okay. So hopefully that makes sense. So now inside our user microservice controller, we can actually begin subscribing to events or messages. So the way that we're going to do that is pretty simple. First, we're going to define a method. So I'll call this create user because, again, the API is handling the create user endpoint, which is going to forward this message into the user microservice. So we need to make sure we are also handling that logic as well at the microservice layer. So we want this method create user. And then we need to use this message pattern decorator, which comes from the Nest.js microservice package. Okay. And then you're going to need to pass in the metadata, the pattern metadata right over here. And what this is it's going to match whatever you provided as an argument for pattern right over here. So notice how my pattern right over here is command create user like this. So it needs to match this one as well. Okay, so that way it knows which correct pattern to listen to subscribe to basically. So we're going to pass in command and then create user. All right, so now inside the create user method, inside the arguments, we can use this payload decorator, which is imported from the Nest.js microservice package. And then we can use this to grab the payload that was sent from the API to the NAT server to the microservice. Okay. And what I'll do is since I'm in a completely different project, I don't have the create user DTO defined in here. So what I'll do is I'm going to just go ahead and copy this class right over here. Okay. And I'm not going to actually worry about the validation at the microservice part for now. You could handle validation here. I think you should be able to. But let me go ahead and create a new folder called DTOs and create user.dto.ts. And I'm just going to ignore all the validation, all the class validator decorators for now, just to keep things simple. Okay, and then we're going to go ahead and import create user DTO. And now let's go ahead and actually console log data. And I'm also just going to return data as well. Since we're using the request response message pattern or message style, we're going to return something back to the API gateway. Okay. Now, before we move on, the last thing that we need to do, of course, is register this user's microservice controller in our users module. So let's do that. We're going to import that and then put in the controllers array. And then we need to go into app.module.ts. And then we need to import that users module right over here. Okay, so now that we've done that, we can actually make an API call to the API gateway endpoint. So we'll make an API call to create user. Create user will talk to the NATS server and send this command and also send the data. And then the user microservice should receive the data over here. So what I'm going to do is in my Docker process, I'm going to go right over here. So let me click on Nest.js microservice tutorial. So this way I can see all of the logs for all of my processes. And I'm going to go ahead, go into Postman, and I'm going to send a request to the API. And notice how now, so I see the API gateway is logging this. And let's see, let's look at the user's microservice as well. Let's see, the user microservice doesn't seem to be logging anything. So actually, the reason why you're not seeing anything being logged in the user's microservice and it's not being delivered is right over here in our users controller for the HTTP API gateway project. I actually need to use this return keyword to return this call over here. I'm not entirely sure why we need to return, but you can see now by adding the return, and if I look at the logs for everything, if I go back to Postman and send something, you can see now it's being logged on both the user microservice and the API gateway. And when I don't have the return keyword, okay, you can see that when I click send, it only gets sent to the API gateway. So I'm not really too sure why that's the case. But yeah, just make sure you have this return keyword for this NATS client.send method call. So I actually just checked the docs real quick just to make sure that you all are aware of this as well. So the return value of the .send method returns a cold observable, which pretty much just means that you need to subscribe to the observable for the message to be sent. So that's the reason why we were not seeing the message being logged. We were not seeing the payload being logged in the User's Microservice app because we didn't actually subscribe to the observable. And the reason why we can subscribe to the observable using the return keyword by returning the observable call is because right over here in this documentation, it tells you that you can actually have Nest automatically subscribe to the observable by just simply returning it. Okay, so then that will actually subscribe to it, then that will cause the message to be sent to the user's microservice. So just know that you need to make sure you return this method call, this.nats client.send. Okay, so let's just go ahead and go back to Postman, click send. And you can see in the logs that we have these objects right over here being logged once in the API gateway and once in the user microservice. So one thing that I do also want to mention is that if I go back to the user microservice and whatever I return here is what is actually going to show up right over here as the response. So basically, let's say if I want to return the actual saved user, or if I just want to return anything I want, let's just do something like message success. This will get returned back to here, to this observable, and then this will return that data back to the client. So you see how I can change the return value very easily. So just wanted to mention that as well. Okay, so before we move on to connecting our microservices to a database, I want to show you one more way of how we can send messages by using the event-based approach. So what I'll do is I'll just set up a simple, let's see. So what I'll do is this. I'm going to go ahead and set up the payments controller for the API gateway because we're going to do it regardless anyways. So I might as well just do it now. So I'm going to create a new folder called payments, and this will also be this will also have a payments module. It will have a module similar to the user module like this. Okay, and I'll just actually just copy this whole thing and paste it in here because I'm going to need them anyways. We're going to need the NATS client module as well. So that's going to be imported from the NATS client folder and the NATS client module.ts file. Let me remove this. Let me just change the name from users module to payments module. Now go ahead and create a controller. I'll copy this, and let me create a new file called payments.controller.ts. And remember, we're in the API gateway project right now. I'm going to paste this in. I'm going to remove the things that we don't need. So I'll just delete all this for now and just change up everything that is referencing users. So I'll remove users and replace this with payments. And then I'll remove this users part and call this payments controller. We'll still have the same thing for the NATS client because we still need it. And now what I'll do is I'll go into the payments module. I will import that payments controller that I just created and pass it into the controllers array right over here. And then now we need to go into app.module.ts and import the payments module. Okay, so let's just double check, make sure our logs are good. Okay, and it does say payments controller is successful. It mapped the payments endpoint, so that's good. Okay, so now what I'm going to do is I'm going to go into the payments controller, and we're still in the API gateway project, and I'm going to go ahead and set up a create payment method handler for the post request for payment. Okay, so post is a decorator that we are using right over here. And this is the payment create method. Okay, I am going to set up a quick little DTO for this. So let's create a new file called create payment.dto.ts, and then export class create payment DTO. And for the, for the class fields, I'm only just going to have one for now. I'll just have an amount, and let me go ahead and make sure that this amount is in fact a number and is not empty. Okay. And then we'll go ahead and grab the request body for our post request for create payment. So we'll use the body decorator, create payment DTO, and annotate this with the create payment DTO class that we just created. Okay. All right. So now that we have, let me just make sure. Yep, we have validation enabled as well, so we're good. So now what we want to do is we want to send an event to the NATS server, and the NATS server will send that to the payments microservice, not the users microservice, but the payments microservice. Okay, because remember, you want your API gateway to forward those messages to the correct microservice. That's the whole purpose of this. So what we're going to do is we're going to reference this .NATS client, and instead of calling .send, instead of calling the send method, we're going to call emits. And then the pattern is just going to be a string. So I'm going to go ahead and call this event create payment, and then pass in the data, which is just going to be create payment DTO. And that's it. Okay, the return value of this is also an observable. But remember what I said earlier, if you don't care about the return value, then you don't even have to worry about returning anything here, because typically, if you want to go with an event-based approach, it's ideal for just emitting the event, letting the microservice do its thing, and returning a response right back to the client, and you don't have to wait for that event to finish processing. Okay, so that's one thing to consider whenever you want to go with event-based approach versus the request response message style that we just did earlier. Okay, so now we're going to go into the payments microservice project that we haven't really touched at all. We do need to install the Nest.js microservice package as well as the NATS package, and we also need to configure everything else. So it's going to be the same exact thing as the user microservice. So let's just do that real quick. I'm going to go into my Windows PowerShell, and I'll cd into payments microservice. Let me clear up my console. So I'll type npm i @nestjs/microservices and then NATS. Okay, so while that's installing, I'm going to go ahead and let me just collapse the project over here. And I'm going to go ahead and delete app controller.spec.ts, the app controller file, and the service file, because we are not going to use those. And let me go ahead and go to app.module.ts, remove these file imports, and remove these references in the module. All right, so now for the main.ts file in payments microservice, it's going to look exactly the same as the main.ts file in users microservice, and all of your microservices, its main.ts file will look pretty much the same. So it's going to be the same exact thing right over here. So I'm just going to copy this whole thing, and I'm going to go ahead and just paste it. So right now I'm inside the main.ts file in payments microservice project. I'm just going to paste this all over here, and I'll just change this to payments microservice is running. And we have the NATS server being connected, and we're running app.listen. So we should be good to go. Okay, perfect. And now we need to do the same thing for the app.module.ts. So we're going to set up a payments module as well, because remember, we need to have a microservice controller for our payments microservice in order to actually subscribe to those events from the NATS server. So I'm going to create a new folder. I'm going to call it payments, and I'm going to create a new file called payments.module.ts. Okay, and then we're going to import module from Nest.js common. I'm going to use the module decorator and create a class called payments module, and then we need to pass in the imports array, controllers, and providers. Okay, And we also need the same, let's see, just make sure. Okay, yep, we actually should be fine. I'm just trying to make sure everything is the same. Okay, which it is. Okay, perfect. So still back in the payments module inside the payments microservice project, we're going to go ahead and create a new file called payments controller.ts. I'm going to use that controller decorator that I need to import from Nest.js common. Okay, and then this is going to be a microservice controller, so I'll call this payments microservice controller. And now let's register this controller inside the controls array in our payments module. So that's going to import up there. And then we're going to register the payments module in the app.module.ts by just importing that module. Okay, so we're done with that. Let's just double check the logs. Oh yeah, our app is currently down. Let me rerun Docker compose up -- build. Okay, shouldn't take too long for it to start up. Okay, so while that's starting up, I'm going to explain what we're going to do inside the payments microservice controller. So we're going to do the same thing that we did in the users controller, in the users microservice controller, back in the users microservice project. So we're going to create a method inside the class that is going to handle whenever we receive an event. And in order to receive the event, we're going to use a different decorator from the Nest.js microservice package. It's going to be called events pattern. So not message pattern, but event pattern. Okay. So our application is running. You can see now in the logs, it says users payments microservice is running, and then users microservice is running, and then the API is running as well. So that's perfect. So everything is up and running, so that's good. So let's go ahead and use this event pattern controller, or sorry, this decorator, and it gets imported from Nest.js/microservices package that we just installed a few minutes ago in the payments microservice package or the project. And then right over here as an argument, you just pass in that same exact string that you passed in when you called the emit method. So right over here, I'm in the API gateway project. And remember how in the regular HTTP payments controller, I referenced the NATS client and I called emit and I passed in this create payment string. So this is going to be the exact event that we're going to listen to, just like that. Okay. And now all we do is we just simply create a method called create payment, and the rest is going to start to look very identical. You can use the payload decorator to get the data. So I'm going to call this create payments DTO, and I don't have the DTO in this project, in this payments microservice project. So I'll go ahead and just copy it over, and I'll just remove the class validators inside the payments microservice project. So I'm going to create a new folder called DTO or DTOs. Create a new file, create payment.dto.ts, and then just remove all of the decorators, because the validation will happen in the API layer. You can also do validation in the microservice as well if you want to, but we're just going to keep things very simple for now. So I'm going to go ahead and type annotate this object with this class that I just created inside the payments microservice project. And now I can go ahead and just console log this, and we should be able to receive this message without having to return anything back to the API or back to the NATS server. So let's see. Everything should work accordingly. Let me just double check. Did I register the payments module? I did. Okay, so everything should work just fine. Let's go ahead and let's make sure the users work first. So the users microservice is still working. Let's now make sure the payments microservice is working. So I'm going to make an API call, a post request to /payments. Okay. Click send. Let's see. Amount should not be empty. Oh, I forgot to provide the correct field. So amounts. Let's do 50. And notice how we get a tool1 created. And if you look at the console, or if you look at the logs in our Docker container, you can see that the payments microservice is logging out the amount, the object, the create payment DTO object, and it gives us this object right over here, which has amount 50. So that's the data that I just sent. So notice how now I don't need to send anything back, because this is just how event-based patterns work. You can just pretty much emit an event and allow all of your microservices to subscribe to that specific event and have it perform whatever logic it needs to perform whenever that event is triggered. And then that's it. You don't have to worry about sending back a response. So it's different than the first approach that we did. So hopefully you can see the pros and cons between both and understand when to use which approach. All right, so now one more thing that I do want to do before we move on to showing you how we can connect to a database. I really quickly just want to show you what I can do inside this payments microservice. Okay, so what I want to do is I want to be able to communicate with the user microservice, or really any other microservice in general. But I want to be able to communicate with the user microservice in case if I need to notify the user microservice whenever something happens. Okay, so right over here, we're creating a payment, and let's just pretend that we are saving it to the database for now. Okay, once I am done with that, what I want to be able to do is I want to be able to talk to another microservice, so that way, whenever something happens here, I can notify another microservice as well. And the benefit to this is sometimes you might have, it's not as easy compared to a monolith application, because in a monolith application, you have everything under one single code base. So it's very easy for you to communicate with each other because it's all under one process. In microservices, you have to talk to a completely different process. So we have to pretty much send the data via NATS, via TCP connection, using the NATS controller in this case, send it to the other microservice and have that microservice act accordingly whenever it receives that event or that request. In order to do that, we need to make sure that we have the NATS client injected inside the payments microservice controller. So it's similar to how inside the API Gateway project, right over here in our payments controller and in the users controller, we injected this NATS client over here, and we also configured that in the NATS client module and then imported that into the root app module.ts. Okay, so I'm just going to pretty much just copy this whole folder, NATS client. I'm going to copy that, and I'm going to go ahead and paste that into payments microservice like this. Whoops, not in there, inside the source folder. Okay, so just make sure you have this same exact NATS client module.ts inside the payments microservice project, or really any project that you will need access to the NATS client. So now what I can do is, let me just first make sure that there are no errors in our project. Always got to double check to make sure, okay, so the payments microservice is running fine. And let me just register, let's see. I need to go ahead and import the client's, the NATS client module inside the payments module, because I'm going to be using it inside here. So NATS client module, let's just double check the logs. Okay, we can see that the client's module is working just fine. So now what I can do is I can set up a constructor and inject that NATS client. So let's do inject. Let's import the decorator, the inject decorator, and the name of the NATS client. So it's going to be the same exact value that you provided for name right over here. Okay. So NATS service, NATS underscore service, all in caps. And then we're going to name the argument private, let's see, NATS client, and then client, let me check what was the name of it again. Client proxy is the class that we're going to type annotated with. Client proxy. And that is imported from the microservices package, Nest.js microservice package. Okay, so we just injected it into our microservice controller, our payments microservice controller. The logs are good, where there's no errors with this. Okay, so remember, make sure you have this NATS client module set up, because if I remove it right now, you'll see that it should throw an error. Let me see. Okay, yeah, is payments module invalid? Nest.js module. So you can see that right over here. Obviously, this is giving us a problem because we don't have that set up. So that's good. Okay, you can see the logs, everything is working fine. Okay, so now let's go back to the payments microservice controller in our payments microservice project. And what we're going to do is I'll reference the NATS client, and then I will emit an event, and I will simply say, let's see, payment created. And I'm just going to pass in an empty object for now. You can pass in whatever you want, like I said. But I'll just pass an empty object. But actually, you know what? I'm going to pass in the DTO. I'll just pass in the DTO. Okay, so now this will emit the event. It's going to send it to the NAT server. The NAT server will push that event to all of its subscribers. So all of these subscribers to the NAT server that are listening to this payment created event will now actually receive that event. So what we'll do is we will go to the user microservice. And just to keep things simple, I'm not going to create a new controller for now, but I just want to show you how this is going to work. So inside the same users microservice controller, I'm going to use the event pattern decorator. And we need to make sure we match this payment created event that we're emitting. So payment created, and I'll just create a method called payment created. And then we'll just grab the payload. And then for now, I'm just going to leave the type as any for now. And because I want to just show you what it looks like. Okay. If I console log data, you're going to now see that whenever I emit this payment created event, the users microservice controller in our users microservice project will now receive these events, and it's going to log the data right over here. Okay, so now let's go ahead and test everything out to make sure it works. So what we're going to do is we're going to make a post request to our API gateway, to the payments endpoint. This create payment method is going to be called, and it's going to emit a create payment event. Okay, that event is going to be received on the payments microservice layer. So right over here, it's going to receive this event, and then we're going to emit a payment created event. And so the users microservice now will receive that event. Okay, so it's a series of operations happening where we have all of our components, all of our microservices talking to each other. And that is the whole purpose of this video, is to show you how microservices can be configured to talk to each other. So if everything is configured correctly, we should have no problem with this. So let's test it out. Let's go ahead and click send. Okay, so we just clicked send. And now you can see the first thing that happens is we're logging it inside the payments microservice. Okay, so inside the payments microservice, we are logging it. And after it gets logged, we emit this payment created method. And then that payment created method is handled by the user microservice layer. And then we log it there. So if you look at the order of it being logged, you can see that it's first logging payments. It's first logging it in the payments microservice, and then the users microservice. Okay, and you can see that it is being logged in both microservices, because you can see the name right over here of the process, or the name of the running container. Users microservice is logging it, and payments microservice is logging it as well. So like I said, your business logic for each one of your microservice functions can be different. But this is just to show you that, let's say after you created a payment, you want something to happen on the users microservice layer. So you would send an event to the user microservice and process that however you need to. So hopefully all of that makes sense. Okay, so the last but not least thing that we're going to do now is we're going to go ahead and connect our payments microservice and our user microservice to a shared database. Okay, so all we need to do is just go into our Docker Compose file. And then right underneath our NATS service, we're going to configure a service for MySQL or MySQL. Okay, and again, you can use whatever database you want. You can use Postgres, you can use MongoDB, really anything you want. I'm just going to use SQL for now because I personally enjoy using SQL. So first, I'm going to go ahead and call the service name MySQL_DB. And this will also be the name of the host name as well when we connect to it. And then what I'm going to do is I'm going to specify the image. So it's going to be the MySQL Docker image that's going to pull from. And then we're going to specify the port that we want our SQL server to run on. So because I have MySQL installed and running on my own local machine, on my own computer, and the default port is 3306. I'm going to configure the port to be 3307 instead for Docker. Okay, and it does, like I said, it doesn't really matter, but I just wanted to mention that. Okay, so now let's set up the environment variables. So I'm going to configure a few, and what I'll do is I'll just use the ones that I used in my live stream just to save some time. But pretty much this allows me to set up environment variables, so that way whenever it runs my SQL server, it's going to configure the root password, it's going to configure the database that it's going to create upon startup, or when it initializes. It's going to create this test user, and it's going to create this the password for the test user, and then it's going to run it on this port itself. Okay, that's pretty much all these environment variables do. And then the last thing that I am going to do as well is I think that should be it. Yeah, I think this is all we need to do. Okay, so now what I'll do is I'll rerun everything. Let me rerun Docker. Let's just make sure our SQL server can run without any issues. You should see that it's going to pull the MySQL DB image. Let's see. Let's see. I think that's okay. Yep, everything is working fine. The server's starting. I think we... okay, yeah, seems like it's good, ready for connections. And if I look at Docker, we can see that our SQL server is up and running. It's right over here, MySQL DB. Okay, and I can go ahead into the shell. I can click on exec, and I can just log into the SQL server using that test user that I just created. And remember, that test user was created by simply just providing these environment variables right over here, test user and the password. And if I type show databases, I should see that Nest.js DB database inside our SQL server. So that's good. So now we need to actually connect to the database from the code. So what we'll do is this. I'm going to go ahead and open up a new window, and let me just cd into Nest.js Microservices tutorial. And I'm going to go ahead and cd into, so let's do User Microservice first. Okay. Let me kind of zoom in a little bit so you all can see this. And I'm going to install type ORM, because we're going to use that as our ORM to interact with our SQL database. So npm install npm I at nestjs/type ORM. We're going to install the base type ORM package, and then we need to install the database driver, so MySQL 2. Okay, again, if you're using Postgres or whatever other database you're using, you need to make sure you install the correct driver. So we'll install that for Users Microservice, and then later on, when we get to the payments microservice, we'll install this as well. But I'll do this right after I finish this. Okay, so I just installed all of those 3 dependencies in my User Microservice project, and I'm going to just quickly install it in the payments microservice project as well, just so that way we don't have to worry about it later on. And then once that's done, we'll configure the database connection to our SQL database. I will also rebuild the Docker container as well. Okay, there we go. So we just installed it in both repositories. We don't need to install it in the Gateway API project, because the Gateway API project doesn't need to connect to the database at all. It's just these 2 projects that we have, the microservices, are the projects that interact with the database. The Gateway doesn't do anything with the database at all. Okay, it passes the work down to the microservice, and then the microservice will return data if it needs to, and then the Gateway will return that back to the client. Okay, so let me go ahead and just rebuild this Docker container. Whoops. Okay, so Docker compose up build. Okay, and once that is up and running, we can continue with setting up a database connection. Let's see. Let's just make sure everything is good before we proceed. Okay, so it seems like everything is being initialized. So that's good. Okay, perfect. Everything is up and running. Okay, great. So now let's go into the user microservice first. So inside the user's microservice, I'm going to go inside the app.module.ts file, and I'm going to go ahead and configure type ORM first. So I'm going to import that type ORM module from the @nest.js/type ORM package. So I need to go ahead and call this forRoot method, and then I'm going to pass in an object, which is the type ORM module options. So we're going to go ahead and start out with setting the type. So this is where you need to set the correct type. So since I'm using MySQL, I'm going to select MySQL right over here. And then now the host, since again, remember we're in Docker and we're running the database in a Docker container. So I'm going to use that same host name, which is the service name of the MySQL DB service right over here. So remember how right over here, this is my service name for the MySQL database. So I'm going to use that as the host name like this. Okay, it's the same thing that we did with the NATS server when we connected to it. The port is going to be 3307. Let's see what else. Entities, this is going to be an array. We need the database name, so that will be Nest.js_DB. That is the name of our database that we configured right over here. Okay. Let's see what else. We're going to also use the synchronize flag, set this to true. So whenever we update our type ORM entities, it will immediately update the database schema. So it'll update the columns, it'll create new tables if it needs to, all that kind of stuff. Am I missing anything else? Type, host, port, database. Oh yeah, the username and password. Can't forget about that. So username, test user, password, test user 123. And of course, I would recommend you put all of this stuff in an environment variable. So just wanted to throw it out there. And now let's just look at our logs. Let's just make sure that the user microservice is not having any errors with connecting. And let's see, now it is saying access denied for user. And it says connection refused. Let's see, it seems like it was trying to connect to port 3306. I think I might need to restart this because it seems like it's not retrying anymore. Yeah, I think it retries 10 times to connect to the database, and we just reached the final time. So let's restart the entire microservice. I just clicked on that restart button up top. Okay, so it seems like it was able to connect to it. Yep, type ORM core module dependencies initialized. So there's no errors with it connecting to the database. So that's good. Okay, so now let's go ahead and set up our type ORM entities. So I'm going to create a new folder. I'll call this type ORM, and I'll create a new folder called entities. And then I'll create a new file called payment, or wait, what am I talking about? It's user, sorry. User.ts. And I'm going to go ahead and create a type ORM entity. So first, we're going to create a class. Okay, I'm assuming many of you already are familiar with type ORM, but I will explain what I'm doing as well. So in order for us to create, well, first of all, type ORM entities are pretty much just classes. And this allows you to tell type ORM that this is what our table is going to look like. So type ORM will take this class and it'll translate it into the SQL table, and it'll actually create it. But we need to use this entity decorator in order for us to do that. So let's just, I think it is imported from Nest.js type ORM. Nope, sorry, it's imported from type ORM. Yep, right there. And then I can change the name to be users, because by default I'll just create user without the plural, without the S at the end, but I want it to be named users. Okay, so now let's go ahead and set up a couple of things. I'm going to go ahead and use this primary generated column decorator. So this will take care of generating a unique ID for our user record whenever we create one. So for the ID, I'm going to make this a string. I'm going to make it a UUID right over here. And then we need to make sure we also match the we need to make sure we have these fields, username, display name, and email as well, with display name being optional. So let's start off with username. So let's use the column decorator. And let me just import that decorator from type ORM, username, string. And let's just make sure that we set, let's see, nullable to false. Let's see, at column, nullable false for email. And then string, and let's go ahead and do display name. So display name is a string. It is nullable. So first let me mark this as optional, so TypeScript knows it is possibly undefined. And then using the column decorator for this field, we'll set nullable to true. And that should be it. So let's go back into where we configure type ORM module. So inside the app.module.ts file in Users Microservice, and where we are, where we have this entities array right over here, I'm just going to go and import that user entity and pass it in the array like this. So now, let's see, our type ORM is still working just fine. If there were any issues, it would mention it right over here in the logs. So if I were to go back into the database, let me log in to the database real quick. Okay. And let's just step into the Nest.js _DB database. And if I do show tables, you'll see that we have our users table right over here. So that's perfect. Okay. So now let's go ahead and actually save the record to the database now. So inside the user microservice, where we have this create user right over here, we need to go ahead and inject the user repository, but we're not going to do this inside the microservice controller. What we're going to do is we're going to create a service class that is going to inject the user's repository. So that way we can actually interact with our database. So I'm going to go and create a new file inside the users module in our users microservice project called users.service.ts. And this will just be a class. And then we're going to go ahead and just simply inject the repository inside the constructor args. We need to import this as well. Inject repository from, and that comes from @nest.js/typeorm, like that. And then we need to go ahead and pass in the entity in here. So I'm going to pass in a user just like that. And then we need to go ahead and do private users repository. And then we need to import that generic repository type, which is imported from type ORM. From type ORM. And this is a generic type. So I'm going to pass in the user class over here in between the angle brackets. So that way it knows that we're interacting with the user entity itself. Okay. Now I'm going to go ahead and use the injectable decorator for this user service class. And I need to import that decorator from @nest.js/common. So that way we know that this is a provider. We need to go into the users module.ts file and just import this users service class. So that way we are registering our user service. It's going to throw an error for us, very likely. And the reason why is because, let me show you in the logs. You can see that it's complaining about the users module and its user repository dependency right over here. And that's because we need to make sure we register that entity inside the users module. So it's very easy. Just go into the users module.ts file where you have the imports. We're going to import type ORM module, and let me just import that real quick. So I'm going to import type ORM module from @nest.js/typeorm. Let me just fix this. So type ORM module, and we're going to call for feature, and you just pass in an array of entities. So we're just going to pass in that user entity like this. And now the error goes away for the user's microservice. Okay. So now we're going to go ahead and create a method called create user. And this create user will take in the same object, create user DTO, right over here. So I'll just call this create user DTO, and we'll type annotate this with create user DTO because we have this DTO already created inside this user's microservice right over here. And then what I'm going to do is I'm going to go ahead and declare a variable and assign it the value of this .users repository .create, and you can just pass in this create user DTO. Okay, and now we can just save the user to database. So I'll do return this .user repository .save new user like that. So now let's go ahead into the controller. We're going to the user's microservice controller. We're going to inject that user's service. And that's pretty simple to do. So private users service, and then whenever we receive this message for create user, we're going to go ahead and just do this return this .users service .create user and pass in the data just like that. So now it's going to save the user to the database, and it's going to return that value all the way back to the API layer. Okay, so it's going to return this as a response, and then the API gateway will eventually have that return back to the client right over here. So let's go ahead and test this all out. So what we're going to do is we're going to go ahead and make a post request to the user's endpoint, and we need username field. So I'll do Anson. We need email, anson@ansonthedev.com. And we don't need display name, so let's just see what happens. Okay, and because display name is nullable, right now it's currently set to null. But you can see that now I know that it was successfully saved to the database because it has that auto-generated ID right over there in the response. Okay, and I can go into the database as well. And so I'll do that real quick. Let's see. Let's do select asterisk, select all column from the users table. And you can see right over here that I have that one single user record created. And I'll create another record. Let's do Jack. And let's set a display name. Jack dev. And I can see I have my second user created. And if I select all of the rows and columns, or select all columns from users table, I now see both records in the database. Okay, so that's pretty much all we have to do with connecting to a database. The last thing I'll do is I'll show you how we can connect the payments microservice to our database. It's going to be the exact same thing, but I just want to show you how it will look like when you have a shared database across two different microservices. And I'm going to show you how easy it is to actually just retrieve the data from that same database, even though you're on different microservices. So let's go into payments microservice, and let's do this. Let's go into app.module.ts, and because remember, we already installed all of the packages for type ORM and MySQL in both of the microservices project, so we don't have to worry about that anymore. So let me go and copy over the type ORM module configuration from the users microservice part, and I'm going to paste that in to the payments microservices app.module.ts file inside this imports array right over here. So just like that. And of course, I need to make sure I import type ORM module. I need to make sure I also create my entities as well. So let's go ahead and create the entity for payment, since we're dealing with payments in this microservice. So let's do this. Let's create a type ORM folder. Then we're going to do the same thing, create a new folder called entities. and then create a new file called payment.ts. Okay. Now, one thing that I do also want to mention very quickly is, since we have a lot of the similar things that we're going to be using, like for example, I have the same type ORM folder, I have the same entities folder, and then you're going to come across a point where you might need to share some of these entities, because maybe your payments microservice might need to access the users records as well. One thing that you could do is you can actually create kind of like a node module that has all of your entities defined in one place, and then publish that in like a private npm package, and then install it as a dependency for your project, so that way you can share all of those entities defined in one place in every single project. So that way you don't have to keep creating them over and over again. So let's go ahead and create that payment entity right now. So we need to import that entity decorator first. So let me import that from the type ORM package. So at entity, I'm going to name this table payments, and then let's create the class, call it payment, and then we're going to use very similar decorators that we used, or the exact same decorators that we used for our user entity. Okay, so we need primary generated column decorator as well as the column decorator, and let's call that. We're going to use UUIDs as well. Let's see, and then let's set the ID to, let's set the field name to ID, and then we're only going to have one additional field for the column, and this will just be amount, which will just be a number. And then let's see, I think in the database I can set this to float without any issues, and that should be okay. Now let's go back into the app.module.ts file in the payments microservice project. Let's go ahead and import that payment entity inside this entities array right over here. And then let's just make sure there are no errors in the logs. So no issues in the payments microservice. That's good. It's connecting to the database successfully. And now we're going to do the same thing that we did in the user microservice, where we create a payments service class, and then we're going to inject that service into the payments controller. And then in the payments service, we're going to inject the payments repository so we can interact with the payments table. So create a new file, call it payments.service.ts, and this is inside that payments folder. And then let's just use the injectable decorator from Nest.js common. I don't know why my TypeScript server is always so messed up, because I always have to restart it all the time in order for the imports to work correctly. So that's why I'm doing a lot of manual imports. So I'm going to create this payments service class. I'm going to set up the constructor, and I'm going to go ahead and use the inject repository decorator, and I'm going to pass that payment entity as an argument. So that's going to import as well. And that inject repository decorator was imported as well. And then we're going to name the field name payments repository, and then type annotate this, to be the generic repository type, and that's going to be imported from type ORM. And then in the angle brackets, we just pass in the payment entity. That way TypeScript knows that we're working with payments. So now I'm just going to create that create payment method that is going to take in that create payment DTO object. And we already created that DTO in this repository, in this payments microservice project already. So that's just going to import from the DTOs folder. And all I got to do is the same thing that I did with the user service. So const new payments equals this dot payments repository, and then we just call the create method on the repository. It's the same exact method, only it's just working with payment entity. I'm going to pass that DTO, and then we just return and then call the save method on payments repository, and then we just pass in this new payment object into the save method as an argument. So this will actually save the payment to the database, okay? And then we're going to go back to the payments microservice controller, and I'm going to inject that payments service that we just created. So private payments service, and then type annotate it with that payments service class that I just created. And let's make sure we go into the payments module, and as a provider, we need to add that payment service as well. Okay, I don't think we're quite done yet because we should have an error in the logs because we are using the payment entity or the payment repository. So we need to go back into payments.module.ts, and I need to import that type or module and call for feature, and then pass in this array of entities, and then in that array pass in the payment entity. So again, all the things that I just did is the same exact thing that I did for the users microservice, just for payment. Okay, it's the same exact setup. Okay, same exact setup, everything is the same. Okay, and the error goes away now regarding that payment repository. So now we should be able to create payments. Oh wait, I forgot one more thing. I need to go ahead and actually call this payments service and call the create payment method. So what I'll do is I'll do const new payment equals so since this payments service create payment method is it returns a promise, so it's asynchronous, we're going to use async await. So let me add the async keyword in front of the create payment method, and let me await the method call. So this dot payment service dot create payment, and then just pass in that DTO. Okay. So, and what I'll do is instead of passing the DTO, I'm going to pass in the new payment that we just created. Okay. And this, remember, this is going to be sent to the NATS server, and all of its subscribers that are subscribing to this event will receive this event with the new payment that was created. Okay. So again, this allows you to create distributed asynchronous microservices that don't necessarily need to depend on each other all in one single monolith application. Okay. So let's go ahead and test everything out. So let's see. Let's go ahead and create a payment right now. And we only need the amount field. So let's do 500. Click send. Let's see. Oh, it's payments. Sorry. Click send. Notice how we get a 2-1 created. No response was returned back. That's fine because we're using the event-based approach. So we don't have to worry about that. But you can see now, because in the users microservice, I was subscribing to that payment created event, I can see that it is being logged. And if I go into my database right now, if I show all the tables, you can see that the payments table is created right there. And I can go ahead and grab all of the records for payments. So you can see we have the ID and the amount. So that is how we can create payments in the payments microservice and have it completely isolated from the users microservice. So hopefully all of that makes sense. Now there's one more thing that I do want to do before I end this video. I want to show you how we can actually reference our data in a relational format, because right now we are using SQL, a relational database, and typically with relational databases you'll have data that is relational, okay? And you'll have these responses that you get from querying the database that will have like a bunch of tables joined together. So in an actual realistic application, you'll have your user entity, your user table, having a one-to-many relationship with the payment table, right? Because a user can have many payments and the payment belongs to one single user itself, assuming that that's how we're going to structure it. Because in some cases, you might have a payment belonging to two different users, assuming that you have two users making a payment on one single transaction, something like that. But we're going to keep it simple. So I want this user to have a one-to-many relationship with the payment entity as well. So what I'm going to do is I'm going to go ahead and first update this payment entity. So we're going to need to set this up so that we can actually have type ORM recognize that this is a one-to-many and many-to-one relationship. So in order for this to happen, though, I need to make sure I have all of the entities in both the payments microservice project and the users microservice project as well. So what we're going to do is we're going to go ahead and take this user entity that we created inside the Users Microservice project. And I'm just going to go ahead and create that inside the Payments Microservice. It's going to be the exact same thing. Okay. And then we're going to do this, what we're doing in the Payments Microservice now, we're going to do the same thing in the Users Microservice after. But we need to define the one-to-many and many-to-one relationship between user and payment. Okay. So user is going to have many payments. So that's a one-to-many relationship. And payments is going to have a many-to-one relationship. Okay, because many payments can belong to one user. And a user can have many payments. So let's go ahead and inside our user class, inside this entity, we're going to use the one-to-many decorator, and that's going to be imported from type ORM package. And then we need to specify the target relationship. So the type of this is going to be payment. So we need to import that payment entity that is already created from before. And then we need to pass in the inverse side right over here. So this is going to be a callback function, and the object here is the payment itself. And then we need to actually define this field in the payment class. We'll do that in just a bit. But the field is going to be this user field. And currently it gives us error because it doesn't exist, but we're going to create that in the payment entity in just a bit. But the field over here is going to be payments, and the type is going to be an array of payments, because remember, a one-to-many relationship in TypeScript, it's going to look like an array of all of the payments for this user that relates to this user. So now we have to go to the payment entity, and we need to define the many-to-one relationship. So we need to use the many-to-one decorator, which is also imported from type ORM package. And then, very similar to what we just did with the one-to-many, we're going to go ahead and pass in the target as the user. So we need to import the user entity. And this user entity, remember, is what we just created in this Payments Microservice project. And then the callback function as a second argument over here, we're going to have this user object, and we just simply reference user.payments like this. Okay. And then for the field, it's just going to simply be user, and then the type is going to be user. Okay. So hopefully this makes sense. And one more thing that I will do is I'm going to use this join column decorator. So that way I can join this very easily. You can see that it says it can also be used on both one-to-one and many-to-one relationships. So that way, when we actually retrieve the user, we can also grab payment data as well, all in one go. Okay, so hopefully this makes sense. Okay, now let's go into the app.module.ts, and we need to also, whoops, not here. Oh yeah, right over here. We need to also register the user entity as well. So let me do that. And then let's just also make sure we are registering it. Let's see. I might need to use it inside the payment module as well. So I will import this over here. Okay. All right. Let's go ahead and make sure our console, let's see. All right, I'm not sure what was going on with that, but I had to manually restart the container. So now everything is good. And our user entity is being registered accordingly. So that's good. Okay, so let's just make sure we do the same thing for the users microservice. So I'm going to go ahead and grab that payment entity and create this right over here. Payment.ts, paste this right over here. And we need to, oh, whoops, let me move this inside the payments or the entities folder right here. Okay, so they're in the same entities folder. And let's go back into the user entity and add that one-to-many decorator in the field. So like this. So now we're inside the users microservice project, and we just added this one-to-many reference for the payments, and we also create the same exact payment entity in this project as well. So now both projects have both entities, and they're both consistent. Let me just fix this up and import these decorators. Okay, let me also import the payment entity as well. Okay, so now that is all fixed. Let's just register the payment entity as well. And I'll additionally register that in the users module inside this for feature array. Okay. So again, doing the same exact thing for both repositories, just for the different entity. Okay, so let's just double check our logs. Everything is working fine. All right, so now what I can do is this. So whenever I create a payment, we need to make sure that we know who that payment is associated with. Now, since we actually don't have any authentication, we don't have any session data to be able to figure out who the user is. There's no state in our application with our HTTP requests. Just for now, what I'm going to do is I'm going to make it a requirement on the DTO. So right over here in the create payment DTO, I'm going to make it a requirement to specify the ID of the user that we want to create this payment for. Because normally, like I said, if you have authentication, you can just very easily figure out who that payment is going to be for. So you don't need to have it required in the field in the request body. So I'll just do is not empty and then ID, which is going to be a string because remember we're using UUIDs. And I'll just leave it like this for now. Okay. So what's going to happen is we're going to go ahead and make a post request to this create payment endpoint, and then we're going to go ahead and emit the event to the NATS server. The NATS server will send that event all the way to the payments microservice. Okay, our payments microservice controller, we are subscribing to that create payment event, and currently we're only creating the payment. Now I am creating the payment in the database, but I'm not saving the user that it is related to. So first, let me make sure my create payment DTO is consistent across both the gateway project as well as the payments microservice project. So you can see that the payments microservice project has this create payment DTO, that's the same one, but it's missing this ID field. Let me change this to user ID instead. And I want to make sure this is also on the create payment DTO as well for the payments microservice. Okay. And now we need to go back to the payments microservice project right here. And so I'm inside the payment service. And what we need to do is we actually need to grab the user from the database. Now, here's the thing though, because we are using a shared database, we can easily just inject this user repository in our code and grab the user. Now, there are situations where you might not be having a shared database and you might have each microservice connected to its own database or its own database table. And so you can't just easily grab all the data from one single database. You have to talk to the other microservice and grab the data from that microservice. And also, I would also encourage you to not, inject repositories that are not necessarily related with the payment domain itself. So for example, if we were to inject a user service or the user repository inside this payment service class, that would be the easiest thing to do, to use that to grab the user from the database by its ID. But it starts to kind of add more things that are not relevant to the payments microservice itself, because now you're also using the user repository to interact with the users table. So what I'm going to do instead is I'm going to grab that user record from the users microservice as well. And we can very easily do this by, instead of using the event-based approach, we can use the request response approach. So that way we can at least wait for that response to come back from the user microservice before we proceed with anything else. So first I need the user ID. So I'm going to go ahead and do this. I'm going to destructure the user ID from the create payment DTO. And I'm also going to grab the amount as well. But since the create payment DTO might also have more fields, later on, I'm just going to destructure the rest into this create payment. I'm going to pack all of the fields back into this object over here. Okay. And I do need to go to the user's microservice. And what I need to do is I need to, let's see, right over here in the user's microservice controller, I'm going to use the message pattern decorator, and I'm going to, I'm going to use a command called getUserById, and then getUserById. And then we need to pass in the ID to the user microservice for this specific pattern for getUserById. So the payload is going to be, I guess, it's still going to be an object that is going to have the user ID. I'm not, just to save some time because we're kind of running out of time, I'm not going to do any type annotation for this. Okay. So what I'll do is I'm going to go ahead and grab the user ID from data like this, and I'm going to go ahead and go into the user service class, and I'm going to create a method called getUserById, and we're going to pass in the user ID, which is a string, and then all I'm going to do is return this .user repository find one. Let's see, and then I can pass in an option, so I can, well, actually I'm going to do find one by instead. Whoops, I'm going to use find one by instead, so that way I can specify I'm trying to find it by the user ID like this. Okay, and of course this will return the user. Let me see. Finds the first entity. It seems like this returns, yeah, it returns one single user, so that's good. Okay, perfect. All right, so now let's go back into the user microservice controller in our user microservice project, and we're going to use async and await to grab the user from the database. So const find user equals await this .user service getUserById, pass in the user ID like this, and let's see, what I'll do is I'll just return let me do this. I'm just going to return this whole call actually. So return user service.getUserById. So we don't really care if this is null or not, because we'll let the payment microservice handle that. Okay, so this will return whatever the return value is from the database, and we'll get that inside the payments microservice right over here. So I'm back inside the payments service inside our payments microservice project. So I'm going to go ahead and do this. I need to grab this NATS service, this NATS client, in order for me to actually send the message all the way to the user microservice. So we're going to inject that right over here. Whoops. And then let me import the client proxy as well. Okay. And so what I'm going to do is I'm going to go ahead and create a variable called user. And then here's what we're going to do. We're going to reference NATS client, and then we're going to go ahead and call .send. And the command pattern is going to be getUserById. So we need to make sure that matches. And then we need to pass in the user ID that we want to grab from the database. Now here's the thing though, this is an observable, or the .send method returns an observable, so we can't easily just grab it. We can't easily just grab the return value by just assigning it to a variable, because it's an observable. We need to subscribe to it. Now, before, there was a method called toPromise that can pretty much just grab you the return value from that observable. But since it's deprecated, they recommend you use this RxJS operator called lastValueFrom. So I can just import lastValueFrom from RxJS, which is actually already installed by default when you scaffold your Nest.js project. So I'm going to go ahead and just use this lastValueFrom operator, and it's just a function. So I'm just going to call lastValueFrom, pass this over here, and you can also type annotate this as well because it's generic. So I can type annotate it with user. So that way now it knows that this is a user or a promise user, and we need to await this method call. So let me add the async keyword in front here. And then this is how we can actually grab the user. So we should be able to just grab the user before we do any thing with creating the payment. So let me just kind of console log this a few times. Let me do new payment. Let me console log new payment as well. Just make sure everything is happening in sequential order. So now, what's going on over here? Did I accidentally copy? Oh, I accidentally, whoops, sorry about this. I accidentally copied, I accidentally injected the payment service. Let me remove that. And you all should remove that as well. Okay, so there are no errors currently. That's good. So what we're going to do is we're going to go ahead and create a payment by making an API call to payments. We need to make sure we send the user ID as well. So now I need to actually grab a user ID from the database. So let me just go back to the SQL database shell. And I'll use Anson. I'll use that ID. Okay. So hopefully this will work fine. If I click send, okay. Keep in mind, we aren't attaching the payment to the user just yet. I just want to make sure the logs are logging in correct order. So you can see right over here, the payments microservice is logging the user. So it was able to find the user successfully. We were able to log that user, and then it created the payment, and then it saved it to the database right over here. And then right over here, you see that it's being logged in the users microservice. Because remember, in the users microservice, we are subscribing to that payment created event. Okay, so everything is working in sequential order, so that's good. Let me try ahead and create a couple more just to make sure everything is still good. Okay, perfect. And you can see still in the database, if I go ahead and grab all payment records, there's still no reference to the user ID just yet because we haven't attached it. So this is the next thing that we have to do is when we create this user, or when we create this payment, we're going to go ahead and pass in all of the fields and all the field values from create payment DTO by using the spreader operator. And then we're also going to add this user reference over here. So this is going to be the user that we just found, but we also need to make sure we check if user is defined, because if user is not defined, then this is not going to work. So what we'll do is this: if user is defined, we will do all of this. If user is not defined, let's see. If user is not defined, then we can just simply return null, I guess. And then inside the payments microservice controller, we can just emit the event only if new payment was only if new payment is defined. So if new payment, then we will emit the event. So if the user was not found, then it won't do anything. Okay. So let's just try this out. Let's make sure it works. So let's go over here. Let's create a payment now. Let's look at the logs. Okay, and now you can see that when I log this object over here, you can see that the user is actually attached to that payment record now. And it's being logged in the payments microservice as well as the users microservice because we're receiving that events. Okay, if I were to actually just change the ID to something else that doesn't exist in the database, you're going to see now we have null. Okay, and the user's microservice doesn't log anything because it didn't receive that event because we cannot find the user in the database. So nothing actually happened at all. Just wanted to show you all how to handle that case as well. But now let's go ahead and query the database. And you can see now, when I select all the records from the payments table, I now have this user ID being referenced to payments. Okay. And now, here's the thing. So we want to also be able to retrieve users from the database and all of its payment records as well. So what we need to do is we need to set up an endpoint to actually grab all the users. So I'll do that finally, and then we can end the video because I know it's pretty long, but I really just wanted to show this case so that way all of you can understand how this all comes into play. So we're going to go back to our API gateway project, and we're going to set up a GET request. Okay. And then we're going to do get user by ID. And I'm going to go ahead and use a route parameter for the user ID. And I'm going to use the param decorator to grab that route ID, that route parameter. And that's going to be a string. So now whenever I visit /users/ID and pass in the user ID over there, it will go ahead and call this endpoint. And so what we're going to do now is, since we need to talk to the NATS server to talk to the user's microservice to grab the user by its ID, we're going to use request and response approach because we want to make sure we're returning a response back to the client. So I'm going to do return this.nats client.send command get user by ID, and we actually already created this already earlier in the user's microservice. If you look at the controller right over here, we already have this get user by ID already created that was used by the payments microservice. Okay, so we don't even need to do anything else but just send this call to the user's microservice. So user ID will just be the ID, and yeah, that's pretty much it. So let's try this out. So now let me go ahead and grab this user ID. I'm going to go ahead and make a users /ID API call. And now I can see I can actually get that user from the database, but I don't get the actual payments as well. In order to get the payments, we need to make sure that we are also grabbing the relations, any relations that we need. And that's actually pretty simple. So what I'm going to do is right over here where I have find one by, there's actually a second argument that you can pass, or not second. Let me see. So actually we need to not use find one by, but we need to use find one. And then we can go ahead and use this where, which is pretty much, it's very equivalent to using find one by, because in the where object, you will just set the ID to user ID like this. And then outside of this object, you're going to specify the relations. And this is just going to be an array of the relations that you want to grab. So in our case, we want the payments relation, because that's the name of the field that is defined on the user entity that we have right over here. So we're going to specify the relations for payments. So now this should grab us all of the payments now, and you can see that it's right over there. So that is how that works when it comes to grabbing the user and all of its payments. Okay, and because it's all connected to one single shared database, it can very easily just perform one query and grab all of the relational data that it needs. So hopefully that makes sense. And of course, if I were to pass an invalid ID, it should just return nothing. But again, ideally what you would want to do is you would want to get the return value from the microservice. So in our case, when we call the get user by ID from the user's microservice, this will just return whatever is returned from the user service method, which is right over here. So this will return the user or a null value. So we pretty much want to subscribe to this observable and grab that value that was returned. And remember how earlier I said that we need to use the last value from RxJS operator to do that. So I'm just going to do that very quickly. So const user equals awaits last value from. That's going to be imported from RxJS, pass in this NATS client.send method call. And let's just add the async keyword in front of the get user by ID method. And so what we can do from the API, from the HTTP API layer, is we can say if there is a user, we will just return the user like this. Otherwise, we'll go ahead and throw a new HTTP exception, and we'll just say user not found, and the status code will be 404. So now watch this. If I click send, we actually get a 404 not found error. But if I were to pass in the correct user ID, let me see. Did I put the right one? There we go. Okay, yeah. So that's the right one right over here, and we actually get the user back. Okay, so now you can start to see that we have a microservice architecture. We have one API that forwards the message to the correct microservice. We let the microservice do all of the database reads and writes. It'll send the message back to the NATS server. The NATS server will send that back to the API gateway, and the API gateway will just send it back to the client. Okay, so instead of having your API server doing everything, you pass off that load to the corresponding microservice. So I very much hope that this whole video was informative to you all. I had a lot of fun making this video. All of the code that I wrote in the description, everything that you see over here, the Docker Compose file, all the Docker files, everything will all be in a GitHub repository, and I'll leave a link in the description so that you all can use it as a reference. I want you all to be able to understand how this works. So if you have any additional questions, feel free to join the Discord server that is linked in the description. Ask your questions in the comments down below. I check my comments every single day, so I'm more than happy to try my best to answer any questions, because I understand that this topic can be a little bit more abstract to understand. But hopefully that this video showed you how all of this stuff works, and maybe you can even build something on your own, because like I said, there's countless amounts of approaches on how you can set up microservices. So I would very much love to hear what you came up with. So thank you so much for watching this video. I hope you all enjoyed it, and I will see you all in my next video. Peace out.